customers. So it has to be some kind of like in the form of report, right? So again, I will let it run. So you have different options. Either you can run the section, sorry, or maybe you can just click it here. And again, it has also options. So for example, you can hide the code also. Let's say like here is option, hide code. You just share the results. That is also fine. But for now, I want to show you code because so you will get the idea. So now we access the data. As you see, we have done like 3-4 times checking if we have accessed the right data or not. So from the source Excel file to MATLAB live script. Now, so once I will just put some comments here. So what we are doing. So for example, we are, let's say like title, kind of like data analysis using flight data. So, and then let's say like I put this setting as import data. So this is very useful whenever you share with the people who haven't worked on this. So they will get intuitively the documentation and then they can understand what's going on. So once you access the data, so next thing is very important to visualize. So to check the data. So you might have used the plot, right? But today we are talking about low code. So what we'll do. So that's where comes this task very handy. So here it gives you create plot. So let me make it bigger. If you see here, it is giving you like plethora of options, like lot number of like different options. So let's access our data, flight data. So we have time access. Then let's say like I want to do some normal line plot across, let's say like I go with oil pressure sensor data. Automatically it's generating the plots here. So if you see here one this option, I can get the control code. So kind of like the code along with these control options. So I'm not writing single line of command, if you can see here. So we'll come this later. So one thing you see, there is some sensor dropouts happening. So since it is MATLAB, the plots are not static. So you can do pretty lot of things with this. So just to see what's going on. So in normal scenario, it's not possible to get the sensor dropouts to 0. So this is something visual checks one can do what's going on with my data. So something I need to address this, right? Then let's see what's happening with other sensor data. I now check with oil temperature. So we see kind of like sensor dropouts are happening. So which is not normal. So this is something one can get through visual checks. So since this is flight data, so it's important we can see from where the flight is starting and where it is going, because that is kind of like make more sense, right? So for that, I can, let's say, like go with this latitude and longitude. So maybe like, let me, sorry, longitude and latitude. But this is kind of like giving me information what I want. But this doesn't give me full picture, right? Because as I said, this is the flight data from Halifax near to Canada to the Detroit, kind of like one of the US location. The data is, but I can't see from this graph, and that's where I need to see some different plots. So again, it gives you different options. So let me fix this again. Latitude, right? So as I said, this data or the flight data is from this Halifax to Detroit, but we see one issue here is the data logger is not stopped. So there is some issue. That's why the flight is indicating it's going to the west of Africa. And this is something we need to address also, right? So how we do that? So let's see. Still, it doesn't give me good look and feel, right? Now it's better than that line plot, but it's still not giving me the way we see our like maps and all those things. It's not giving me because the base geoplot uses two-tone approach. So let's say like we stay with this, and what I should do. So I do need to just adjust this. The best thing to go ahead is with our documentation. So that's something we keep standard across all our functionality, and they give us like various options, like how you can use this functionality from MATLAB. So and it gives you different options also. Let's say, for example, I pass latitude, longitude, or different very kind of like parameters. And this is what gives me more intuitive like information about that flight data. So maybe like I need to adjust some geo-based map, or let's say like you are doing different analysis on like kind of like with this street analysis, then you will be using that different base map, right? Geo-based map streets. Likewise, so this is very useful documentation page. So what I will do, I'll just copy that geo-based map. Okay, and I can add a little bit beautification. So for example, line width, for example. So it's kind of like tab space in your keypad. You just need to just do tab space. It will give you different options which you can use. Now, let me run. Now, if you see, it's far better than what we had, but still we have issues here that this flight data is kind of like suggesting me this flight is going to west of Africa, but that's not the case. So this is something we saw three issues. One is like those oil sensor data kind of like dropping to zero, then oil pressure, then and this one. So what we should do, right? So first thing now, as I said, we are modeling this true airspeed. And if you see, this is what the beauty of accessing the data in the tabular. So it gives you so a lot of such options to do directly with your data. You don't need to write, so automatically it will take care of writing code for you. So it's not possible to have true airspeed kind of like zero, right? So what I will do, like I'll just truncate that. So starting with 10, that's something I will, and I'm not considering this nans. One can do that, but for now so if you see, the code is updated automatically. So let me adjust that. Why 10? It's just kind of like random number I'm choosing to see if I can fix my problem. So because the sensor logger has made some mistake and it was kept live, and now my flight is the journey is looking good. So it's coming from Halifax to Detroit, not going to West Africa. But if you see that number 10, I choose randomly, and that should not be case, right? And that's where the controls come into picture. So I want to play with this number with over the range of values. So how you do that? So let's say like these are different controls. So you select from when you go to live editor in the control option, and you can configure them. So let's say like minimum value is 0. I put max value of true airspeed 400 with the range of 10. Like whenever I like click, it will go with, and not only this section, but let's say like I want to change all section after changing value. So if I go 0, we have that original problem what we had, right? And let me just come on. Now this is not anymore. So I can play with this number. I don't need to kind of like put for loop to carry out. So I can analyze that data or the this range of values. So let's see, we don't have issue with 10. I'll just stay with this. So we fixed that one issue, but still we have two more issues. So it's not for today's demo. I'm just staying with this subset of issues, but you in your day-to-day projects, you can see more such kind of like analysis, in-depth analysis to see what kind of issues you can see in your data before you go for model development. So what we should do now to clean the data. So because we saw there are like sensor dropouts, there might be another also such issues in the data which I'm not aware of. So either I can do this programmatically. So like there are like one-line commands to like fix missing values, like remove nans or maybe like some outliers. But since we want to do this low code approach, if you go into this home tab, you will see this tool called clean data, and all our such these apps, they generate MATLAB code for you. So you don't need to write the code specifically to do that. So that makes your life a little bit easier. So let's access that data. So for example, which we are working on, and you get various range of different algorithms or approaches like clean missing data, clean outlier, normalize, regularize. This is something very, so all are important, but regularize, for example, you are based off Turkey and you have your customers in different geographical locations. It may happen that they have access data with different time stamp range. And let's say like one is hourly based, one is minute based. So how you can regularize in order to use that data set. That's where the regularization come into picture, and you have also both different options. And here you get this statistical information of all your variables. So in one place altogether, like how it is happening, what is the minimum value, kind of like this information also is useful when you are creating your own, let's say like uh, based on that statistical information, the algorithm development. So now we want to work on this oil pressure and oil temperature. So let's see, I want to just work on clean outlier. You can do pretty much many things, not only just one. And it's loading those all kind of like basic parameters kind of like along with the data. So which, for example, we are working on this oil pressure and oil temperature. So maybe it's look better here. Let's say like I want to, you can remove outliers, fill outliers. The different methods are there. Kind of like, let's say like I want to go linear interpolation, for example, or moving median. So it's kind of like we have documentation for this also, how you can use. So for example, let's say like I want to have window of uh, kind of like 100 data points. It will pass that algorithm within that data. And let's say like this is randomly I'm checking how you want to see the data. And what's happening here is like, for example, we had that outliers, and let's see like how it looks like. Now we don't have those dropouts, which was the case in earlier scenario, right? So it's you can do pretty much kind of like little bit thorough analysis also how things are working here. Let's see. How it's applying that outlier threshold and then trying to find out how to fill that outlier. So, and as I said, from here, either you can export that clean, but as I said, we are not working on one file. We want to use it for multiple such data samples, sorry, multiple such Excel files. So the best thing will be like generating script, right? So I will write here like clean and save as mat file. And again, I want to use this for our next step. So I can put a little bit nice name here. Let's say like clean data. Okay, so now we try to address those outliers issues, uh, kind of like this, not the sensor value logging issues. So where we should go now? Now we reach to the stage of creation of the data set. So from here onwards comes your model development. Uh, So since we are trying to find out the number based on that multiple sensor value, this problem is comes under the regression. If you want to do some classification, there is classification learner. And if you are not aware how I can use different sets of algorithms, so there is like automated machine learning also. But for now, we'll stay with this regression learner. So that comes with statistical machine learning toolbox. So one thing you would have realized, I'm just using those low code tools and generating MATLAB code. And that's basically the goal of this today's session is like how you can make your day-to-day work more efficient, saving your time and doing a lot of more experiments with different approaches. So we have the data. And you will be seeing also now how we can do such analytics workflows also. So flight data was the original, and then we did some cleaning. And if you see, we want to predict true airspeed, right? So either you can select all these features. So it's very small feature set, but still, if you want to, and here you want to put some data, you don't want to use all data for your training purposes. There is different ways how you can do this. So let's say like, since we had just one file, but let's say like you have thousands of files. So there is different parameters like you want to distribute between 80 to 20, 70 to 30. There is no fixed rule, but it's kind of like useful analogy to keep test data aside, which is not part of your training. And these are some kind of like cross validation. So it's basically is kind of whenever you have limited data, you want to do some kind of like cross validation to avoid overfitting. So these are some machine learning concepts which is very useful when you are generating very efficient models. But you don't need to worry if you are not aware of this because there is on-ramp programs which are free of cost where you can learn those things also. And let's say like we keep aside 10% of data. Now where we should go, right? So if you see here, I can do some feature selection. Uh, for example, it has some, let's say like this is maximum relevance, minimum redundancy. It gives me which features are contributing. So based on that, I just select top five features, 10 features. These are like set of algorithms applied on your data. So you see, for example, today we have just 13 features here, but not necessarily it should be 13 features in your case, maybe like you have 300 features, more than that. So in those scenarios, it plays more role how you can select like top features contributing in your data and then just train algorithm in those limited feature space so that you save your time and you save your computing power also. So I'm just running on this kind of like feature importance calculation, feature ranking algorithm. It will take a little bit time because this is a little bit complex stuff. I'm trying to see how we can get some kind of like more intuitive importance or the information from the data. And there is kind of like principal component analysis also. So that is also kind of like widely used in statistical approaches when you are developing your machine learning model. And we do support some kind of like patient optimization. So you see here, it's basically kind of like more intuitive than those maximum. So here, let's say like I want to go with first 5 features, and that makes sense. But I'm not doing that. I'll just stay as it is. So which algorithm to select? That's something questions many people have in their mind. So because in paper there are like hundreds, thousands of papers for doing such kind of things. So first thing what we suggest is go with this all quick to learn. So we have some set of algorithms which work for the regression, very pretty straightforward set of hyperparameters are already selected for your data. And if you see, I'm using use parallel. So it's very important if you have paracomputing toolbox and if you have multiple core system in your system, or maybe like using cluster, it will train your algorithm on different like multiple cores at simultaneously. So let me run it. So underneath it is running on this parallel cores. So if you see, I'm running at the same time multiple algorithms. This is how you can see in the response plot which one to select based on that. Let's say like this find tree. So root mean square error. So what we are doing is basically like we are trying to find out how the actual value and the predicted value, how far they are. So lower is the better. So for from this set of algorithms, I see this find tree doing pretty much good job for me. You can do a lot of this visualization of your results, how it is behaving. So for example, if I see linear regression, this is pretty bad as compared to this fine tree, right? So then if you remember, we kept this 10% data in the first place, like we didn't use that for training. And we'll come to this later. And here, either you can load your own data, but we already have kept 10% for today's work. But pretty much you can also load and test it itself here to see how your model is behaving that. And if you see, it's pretty much giving us good result as what it was in the during training. Let's see how it is doing with linear regression. Not that good. So as we see with fine tree. So then this is kind of like traditional your training and the testing, but most important, that's kind of like in across the globe, you need to explain now how your model come to that conclusion. So we have added in our this toolbox this explainable features like explain AI. For example, this is Shapely. This comes from this financial background. So what is trying to find out how those features are contributing in your prediction. So we use those 12, 13 features. And now whenever we do prediction, which feature is contributing in that particular prediction. So it really makes sense. For example, altitude. So since most of you who are related in this industry, they can relate this true airspeed whenever it's in altitude phase. So very high altitude, it's kind of like it has this cruise mode, right? Whenever it's taxiing, it has kind of like low true airspeed. And these are like different parameters like latitude, longitude, how that particular feature is contributing when we are doing this prediction. So this is pretty much giving us a full picture. So you can do not only shapely, there is partial dependence, lime, and all those things, and you can export those plots and maybe like share with your colleagues and with your stakeholders. So now I'm fine with this fine tree. And what we do, so either I export that model as mat file with those trained weights and parameters, either I can directly deploy that into production server. So this is one of our product where you want to integrate with, let's say like with REST API. So where your stakeholders or the customers, partners wanted to access, so they will load their Excel file and see true airspeed for that particular file. So that's where this deployment come into picture. Or maybe you want to create some experiments. As I said, it's for today's demo, we are staying with just one example, but you want to try out different experiment, different hyperparameter settings. So we do have experiment manager where you can see which hyperparameter, which algorithm is working very well on your data. And the people who are working in Simulink, so you can export this now model directly into that Simulink block. So you can use in your Simulink ecosystem. So pretty much doing many things in from one place. But for now, I'll just generate the function since we want to use it for multiple purposes. And if you see, it's basically giving me entire how I can use it, how I can use for prediction, and then different parameters which we selected, right? So let me come and save this. Hope there is no different. So how I can use this? So it's pretty standard. We already did with the test data. I will come back to my live script again. So here T is like our clean data. So this is where the model is trained, and then we'll use this prediction. So here it will tell us how to use that also. So if you see, we had that 0.6 in the app. Similarly, we are getting here results. Let me do some section break. So I can use from here itself, but right now we don't have separate any the test data. I'll just directly pass this clean data itself. We should not do that, but right now I don't have any option. So I'll just use that. So this is how we are getting the true airspeed for that data. So pretty much we have done that prediction. So where we go now, if we are happy with whatever we have achieved so far, let me save this first. Because demo. Now I can export as PDF, Word file, HTML, pretty much. Even I can export to Jupyter Notebook, but I showed you PDF, so I will again export it as a PDF. Right. So this is what we did from last, I don't know, 50 minutes. So we imported data. We can format that. It's not that sweet the way which I showed in the first place, but it's basically everything what we did. So then we did some visualization. Then we did some cleaning. Then we went for regression modeling, and then we predicted our data. So now I come back to presentation. What we can do with this, we can generate that PDF report, but it's not just once we need to do some kind of like this automation. So that's where this deployment topics come into picture. So I showed you the import tool, and it's not only just one tool. We have like hundreds of such different tools coming with different toolboxes. For example, your data may be like in such relationship databases. We do have this database toolbox, which also comes with this database explorer tool. And then these are like different environment, how you can directly access the data. So it's not only just engineering data, we do support this business data, and even you can access data basically from anywhere, like cloud services and all those things. And then in data analysis, we saw visualization, we saw those pre-processing kind of like apps, which does, and we do have very domain specific. Let's say like you are working in image processing data, 3D data, 2D data. They do have their own specific apps. For example, thresholding, or you want to do some kind of like segmentation, labeling. That also you can carry out. We didn't have time to talk about AI, but we do have very much, very much high development or investment in AI space, where we also provide app there. Either you want to train your data like algorithm from scratch, or transfer learning approach, or if you want to take your models from other framework, that also you can do. We showed you, like we saw how you can export that result, put some kind of like animations, or like we didn't went that far, but to put your kind of like own images, custom images, to make it look and feel good. Then finally you can export that also PDF, Word, LaTeX, and MATLAB is growing as customers' needs are going. We are addressing each and every those two releases here. It started with this simple command to now scripts. Now when you go for this very advanced software development, you can see we do also have support in that space also. Now, there are MATLAB projects where you want to integrate everything and do some dependency analysis, have source control. Then projects are very much useful. Uh, and basically, we integrate with all those CI/CD, continuous integration, continuous deployment background. We do have some testing frameworks also, and not only you can do all things with MATLAB, but we integrate with other programming frameworks also, such as Python, Java, REST, and so on. So you can bring your networks from other framework in MATLAB and pack it together. And if you are working in continuous integration space, basically we integrate with most of this very standard like GitLab, Azure pipelines, all those CS uh, frameworks, and you can use MATLAB anywhere. We added this extension for Visual Studio Code. So the people who are doing very advanced software development, it's kind of like very handy for them to have MATLAB there where they are developing their software with other frameworks. Basically, we do have this GitHub repos where you can run those kind of like scripts in MATLAB online. Talking about Python, there is task also, how you can run Python code in MATLAB. You need Python install in where MATLAB is. You can call MATLAB from your Python also. For that, you need MATLAB engine. So we have added a lot of support in that space. We do, as I mentioned, we do co-execute with this open source frameworks when you are going with AI space. There are kind of like deep learning blocks also added in Simulink. You can generate code basically for, let's say, like this library free source code like C++, or CUDA compiled code, or maybe like your chips, FPGA chips. This is how the big framework looks like in all those accessing data till the deployment or sharing your application with your colleagues, customers, or stakeholders. And here is how our big picture looks like. You write once, that's what we did. And then for the deployment, either we have this create exe file or web app, or share your web apps for web app server, or as I said, either you can pack that as and create kind of like microservice also, or maybe like on REST API, sorry, RESTful web API, you can integrate also where you can share over open internet. And similarly, same code with the coder products, you can take it to different embedded hardware too. So this is what pretty much I wanted to talk about today. And these are like learning resources. If you have, if you are interested, if you are dealing some kind of like similar problems, please have check out this MATLAB Central, where a lot of active community support from our staff and from MATLAB champions and many people who are using MATLAB across the world. They're sharing, and there are some very expert blogs. There are like examples from industry specific also. We have very great support, and you can contact FİGES also for your support stuff. And but there is a lot of things from other side like training, consulting, workshops, technical supports. There are some courses also if you are new to MATLAB, how you can learn MATLAB skills. And this is something I mentioned, on-ramp programs, which needs MATLAB Mathers account, but it's free of cost. So you can learn many things which I talked today, like about machine learning on-ramp, where you will learn those different techniques about maybe like decision tree, how it works, or support vector machines, and so on. And with that, I would like to thank everyone for your time.